Now we will discuss various statements on second law of thermodynamics. So before we go for the statements, let me tell you the purpose of second law. Okay, so the intention of second law. What does the second law telling us? So the first one is, the second law is actually giving an idea. Okay, so it gave an idea on how a natural process can proceed. I mean, it gave an idea about direction in which the natural process can proceed. Okay, so gave an idea on direction. Okay, gave an idea on direction. You can write this way in exam. Gave an idea on direction of natural process, that is spontaneous process, in which direction it can comfortably takes place, you know. So that direction is what is given by second law of thermodynamics. Actually, that is the limitation of first law, isn't it? So the first law could only say the different forms of energies can be interconverted to each other, but it could not tell a particular process in which direction it can proceed with, right? So but here this second law purpose is like, it has given some idea on the direction in which a natural process can proceed, right? Yes. And the second point is, it also said that the entire amount of energy, okay, so the entire heat that is provided, okay, to the system is not converted to work, is not converted to work, right? And some amount, okay, some of heat, some of Q gets wasted into environment, so it disappears into environment, it disappears into the surroundings, and it gets wasted, right? So that is the simple way of telling you all about the purpose of second law. Okay, so point number one is, it gives an idea about direction, and point number two is, what it tells is the amount of heat that you are giving to a system for doing a particular work. You know, the entire heat is not getting used up, some amount is getting wasted also. So this is the main idea. Now different scientists have given different statements. The meaning is same, okay, but they spoke in different terms. So let us see the three major statements. So the first statement is in terms of entropy. So I'll give the first statement in terms of entropy, guys. So with respect to entropy, how do you define the second law of thermodynamics? Very simple. Any process, okay, so any spontaneous process happens with the increase of entropy. Okay, so any spontaneous process occurs with the increase of entropy. Okay, so entropy is nothing but disorderness or the randomness that you studied in the previous video. Okay, so if a system is associated with increase in disorderness, okay, say for example the hotter body becoming cool, it happens on its own, and it also gets associated with increase in disorderness, right? So any spontaneous process happens with increase in disorderness. So that is the statement of second law in terms of entropy. And also, you know, the total entropy of a universe is always greater than zero, or you can mention mathematically also. So the change in entropy, okay, so or you can say the entropy of universe okay, which is actually equal to entropy of system plus entropy of surrounding. Okay, so this whole thing is greater than 0. So this is a mathematical way of representing second law in terms of entropy. Okay, so or you can include the change in entropy also, like this you can write. So entropy of a universe, change in entropy of a universe is equal to sum of change in entropy of a system and surrounding. So the entropy of a universe, if it is going on increasing, then that is what indicating us that particular process is spontaneous. And this is all about definition of second law of thermodynamics in terms of entropy. So now I am going for the second definition. Okay, so this was the previous one which I have shown here. This was the first definition. Okay, yes, and now I am telling you the second definition, which is given by Kelvin. Kelvin's definition we say, and he told differently, the same point but he told differently. So this is Kelvin's statement, Kelvin and Planck's statement. Okay, so what he said is, it is impossible. It is impossible. So we all know this, and I have already said this. It is impossible to frame a process, okay, or a particular equipment or engine, you can say, to frame a process where entire heat supplied, okay, entire heat supplied is converted, entire heat can be converted into work, okay. So there is no such engine or there is no such instrument or anything where the heat, the amount of heat that you supply, can you convert the entire heat into productive useful work? It's impossible. So that is why actually no engine is 100% efficient. No engine is 100% efficient, isn't it? So if you take an engine in automobiles, engine in a car, you know what, you will fill it with fuel. That fuel will burn, okay. When it burns, it will generate heat. So that heat is what gets converted into mechanical work. But will the entire heat that gets generated gets converted into mechanical work? No, some amount of heat gets into reservoir, cool reservoir, isn't it? It will get wasted, right? So no engine can be 100% efficient. Why? Because out of total heat that you give to the system, some amount must get wasted. Only some portion of it gets converted into useful work, okay, right? So this is the statement given by Kelvin, okay, and this is another way of telling second law of thermodynamics. Now coming to the third statement. Now is the third statement, which is called as Clausius statement. Clausius statement. So in simple way, what he tells is, it is impossible, so it is not at all possible, okay, to convert colder body into hotter body without the expenditure of work, without the expenditure of work. So here what does it mean? Converting hotter body into colder body is a natural process. It's a spontaneous process. So that means for a non-spontaneous process to happen. So I am telling the meaning of this particular thing. For non-spontaneous reaction, okay, expenditure of work, okay, expenditure of work is necessary, work has to be done. Okay, so is necessary, which means work has to be done, something has to be done to convert, okay, to convert the colder body into hotter body. Can a colder body becomes hotter body on its own? No, right? Okay, so something has to be done, some work has to be done to convert colder body into the hotter body. Without that you cannot do it. Okay, so that means any spontaneous reaction needs some work that has to be done on it, okay, to see the usefulness, to see the process happening with it. Okay, so that is all about Clausius statement. So the three major statements I have given for you: Clausius statement, Kelvin statement, as well as the second law of thermodynamics in terms of entropy. So this is most important. In case if it is asked only for 1 mark to give a statement, then you can write this statement, okay, along with mathematical form. So that is all about the different statements of second law of thermodynamics.